Okay. What is buffer solution? Okay, so if you think about buffer solution, okay, buffer solution is a solution when you have acid and when you have base. Okay, you add certain amount of acid or base, the pH of that solution do not change. Okay, that is going to be the buffer solution. Like take it for example, what if you have a buffer solution, the pH of that buffer solution, the pH is 5. Let's say when I add a small amount of H plus, it means I go and add acid. Of course, I do expect, okay, the pH should be slightly changed to become 4 or maybe 3. Okay, but buffer solution will be preventing that changes of pH. So of course, it's a magical solution. Okay, so what is buffer solution? It is a mixture. Okay, it's a mixture of two components, okay, that will keep the pH constant. Yeah, that is the function of buffer solution. So what are the two components? Okay, we have two types of buffer solution. One is going to be acid buffer. We call it acid buffer. Another one is going to be a base buffer. So acid buffer, you can see this is the first example for the acid buffer. It's a mixture of weak acid and its salt. Okay, example, ethanoic acid and sodium ethanoate. Base buffer is going to be example. It's a weak base, okay, for example, ammonia, and its salt, ammonium chloride. Now, what does it mean is it's a mixture. Okay, please remember that it's a mixture. So you cannot just say, okay, it's going to be ethanoic acid, CH3COOH. Oh, ethanoic acid, I know they can give me CH3COO minus and H plus. Or they have the weak acid, they have the salt. No need to add anything. No, you are wrong. Yeah, this is not like that. Okay, it means that it's a mixture of weak acid. It's a mixture of the weak acid and the salt of the weak acid. So the salt of the weak acid, you need to add separately, CH3COO and A. This is the salt. Okay, and this salt, okay, they can actually completely dissociate to give you the CH3COO minus and Na plus. So these two combinations are going to be called as buffer solution. Okay, so the salt of the weak acid and the weak acid itself. An example, the second example is ammonia. Okay, ammonia, I know that ammonia, when you want to represent as a weak base, we have to include water, and they will give you a reversible reaction to give you ammonium ion, and you are going to have OH minus. Okay, so ammonium must be coming, okay, in form of salt. So there is another one, which is ammonium chloride is one of the salt, and they will give you ammonium ion and Cl minus ion. So the combination of this and this is going to be known as buffer solution. So you must combine. And I will teach you now how buffer solution actually works. Okay, buffer solution is basically, they are going to work, okay, where when there is going to be H plus is being added, and when there is going to be OH minus being added, those addition, okay, will not change their pH. And I'm going to show you how that thing can be achieved. I'll just show you with the acid buffer. Okay, you have this. Okay, no need to have plus. So this one will give you CH3COO minus plus H plus. And then the salt, I am going to use this as my salt. And this is going to give me Na plus and then CH3COO minus. Okay, I'll try to make it as easy to understand. Okay, you see here, okay, when you have this solution over here, we know it's a weak acid. Okay, ethanoic acid is a weak acid. So the dissociation to form this is going to be not so great. Dissociation to form this is not so great. Okay, it means that they don't dissociate that much. Okay, and then when you look at the dissociation of this is complete dissociation. It means it's going to give you a big amount of this. Okay, there is going to be a big amount of this. And we know in that solution, okay, we have this particular ethanoate ion. Okay, we call it ethanoate ion. We can just simply say that the ethanoate ion, most of them are coming from the salt. Okay, so if you cannot visualize, I'll just use simple terms. Okay, the simple terms is, let's say we go something like primary kid. Okay, if let's say you want to represent this using apples. Okay, you have 100 apples. Okay, and when they dissociate, they give you only one apple. Okay, they give you only one apple. And then, okay, you have 100 apples here. Okay, when they dissociate, they give you 100 apples over here. I hope this one is very clear. Okay, so now if you compare 1 with 100, okay, 100 that comes from the salt is going to be more significant, okay, compared to 1 apple that is coming from the weak acid. Okay, this is very important concept. Okay, now if I am going to introduce HCl into the buffer solution. So HCl, okay, what is important? HCl will contribute the H plus. Okay, so when I introduce this H plus into the buffer solution, okay, what you need to do is, the trick is, you have 2 equations over here. You always refer to the equation that has the reversible reaction. Okay, this is the first trick. Okay, I'm teaching you. Okay, you always refer to the equation that has reversible reaction, or the equation that involves the weak acid or weak base. Okay, now what will happen? Okay, when you include this H plus, okay, you check whether there is H plus in that particular equation. And when you see over here, there is the H plus in that particular equation, which is this one. When I put the H plus, what will happen? The concentration of H plus is going to be increased. So now, even when the concentration of H plus is increased and you have a reversible reaction, according to LCP, what do you expect? Will it go to the left or will it go to the right?
Left.
Okay. Why left? Because you want to re-establish the equilibrium so that you can decrease the H plus. Okay, so it means that the H plus is increased and I decrease. What will happen to my pH? My pH will go back to original. It means I can maintain my pH. Okay, that is the reason. But according to the equation, while you are doing the readjustment, what happened is, okay, when you do the readjustment, I will erase this part now. I'm going to still use the apple concept over here. Okay, when I rearrange this, okay, what happened? Okay, during that process, not only H plus is being reduced. During that process, CH3COO minus is also being reduced. Okay, and at the same time, it is also forming more CH3COOH. Okay, now when this is happening, reduced by how many? Maybe reduced by 1. Okay, reduced by 1. Do remember just now, okay, this one is 100. This is going to be 100 apples. Okay, and when there is going to be formation of CH3COOH, that's going to be, just take it as 1 apple is being added. Okay, 1 apple being added. Now, if let's say Sharon, okay, has 100 apples. Okay, Sharon has 100 apples, and suddenly one of the apple goes missing. Sharon, will you realize that immediately?
No.
Yeah, most likely you will not realize because it's not that significant. Okay, it's not that significant because you have a lot of apples here. Okay, you have a lot of apples over there. And okay, when you have 100 apples, Audrey, and someone suddenly place 1 apple over there, will you realize that you have 101, or do you think it's still going to be 100, Audrey?
Still 100.
You will immediately, you will still think it's going to be 100 because it's going to be not that significant. Okay, you will not be even just at first glance and say something is wrong. Yeah, so that is still going to be, you will still think it's 100. Why? Because of this 100, because of the initial concentration of that. Okay, so it means that even though there is going to be increase of a concentration and decrease of certain concentration because of the presence of the what we call reserve, a large reserve, okay, of this and this, they will make as though whatever that is changing is negligible. Okay, that is what is going to happen over there when you have H plus. Okay, so whatever that I have explained over here, you can go through from here. It's explained over here. Okay, it's explained over here. And okay, I will now explain, okay, about here. If you add OH minus, what will happen? Okay, the same thing. Okay, I have CH3, COOH. They will give me CH3, COO minus plus H plus. I have CH3, COO, and A. Okay. Let's say I am going to add sodium hydroxide. So what is going to come in? It's going to be the OH minus is going to come in into here. Okay. So I told you, okay, if you want to see the relationship related to buffer, you select the equation that has the the two arrows, yeah, the reversible arrow. And then now the OH minus is coming in. First, check, do you have any similar ions? No, no similar ions, which is going to be OH minus like just now. Just now, there's H plus, so similar ion. But now, if there is no similar ion, you have to look for the H plus because OH minus will react with the H plus to give you water. Okay, so it means that when OH minus react with H plus to give you water, then some students might be asking, sir, OH minus also can react with acid, right? Why not? Okay, why not with ethanoic acid? This one, to answer this is very simple. If you have a neutral molecule and then something that is going to be negatively charged, okay, and you have something that is positive and negative, which one the attraction will be greater? Positive and negative, the attraction will be greater. So that will answer the question why H plus is reacting with OH minus, okay, compared to the acid. Yeah. So this H plus will react. So what happened when the H plus react with OH? The concentration of H plus will decrease because it's reacting. Okay. When that happens, okay, Wilson, can you tell me what will happen to the position of the equilibrium now? Is it shifted to the right or to the left?
Right.
Yeah, because the concentration of H plus is decreased. I need to increase it back. Okay. When I increase it back, then only I can achieve the original pH. Okay. So during that reaction, what happens? This one is increasing. By how much? Only 1. But there is going to be 100. The increase of 1, okay, is not going to be significant enough because there is going to be a large reserve from the ethanoic ion, okay, from the salt. And during that process, there is going to be a decrease in here. But how many? Decrease of 1. From where? From 100. Is it going to matter a lot? The answer is no. Because there is a large reserve of the weak acid. Okay, because the dissociation is not so good. Okay, so that will explain everything that is explained over here. This is what we call as buffer solution. Okay, so this is going to make sure, okay, that there is going to be no change in pH. Okay, but do remember, everything have limitation. Okay, if Sharon has 100 apples and then someone take 50 apples from Sharon, she can actually identify. Okay, she can identify. If let's say Audrey have 100 apples and someone surprisingly give another 50 apples over there without her knowledge, when she come back, she will definitely notice that there is going to be additional amount of apple. Okay, so 50 is not something that is negligible. So there is a limitation. Okay, so you cannot add too many. Okay, you cannot add excessive addition of acid and alkali. If you do that, then the pH will definitely change. Okay, it will. There is a limit for the buffer solution. Okay, please remember that. Okay, so writing the equation and how it works and so on. Okay, if you look at this previously, I have explained to you related to acid. Okay, ethanoic acid. Okay, and I told you that we also have, okay, what we call as base buffer. Okay, so we look at this base buffer. Base buffer is going to be weak base with the salt of the weak base. Okay, so you can see they say this mixture, okay, acts as a buffer solution, and I need to explain, okay, how it works. So first thing you need to write down ammonia. Ammonia can behave as a buffer only with the presence of H2O. And then you write down the equation ammonium ion and then OH minus. And then you need to write down the ammonium chloride. Okay, ammonium chloride gives me ammonium ion and then chloride ion. Okay, this is the equation. And now you are adding dilute hydrochloric acid. Okay, so let me actually copy this. Okay, and then put it for the base later. Okay, now, so now, okay, I am going to add, okay, I'm going to add ACl. ACl comes, okay, where you are going to have H plus. So I told you, okay, look at the equation that has the reversible sign. So this equation, focus on this equation. And then when I add the H plus, okay, you check whether there is H plus or not. There's no H plus. So next is to check H plus will react with what? H plus can react with this. It can also react with this, but it will react with the OH minus. Why positive and negative? Okay, the same explanation that I gave you. Okay, so this after H plus react with the OH minus, the OH minus is going to concentration will decrease. When this concentration decrease, what will happen? The position of the equilibrium will shift to the right. When that position of the equilibrium shifted to the right, okay, the OH is going to be coming back as normal. Okay, the pH remains the same. And what happens here? Maybe increase of 1, but they have 100. Nothing changed. Okay, they have 100, but they decrease by 1. Nothing changed. Okay, that is going to be explained. Okay, you can just see from here. Okay, they have explained over there. The same thing, okay, if I have, okay, let's say, for example, I add sodium hydroxide. So sodium hydroxide, OH minus. And I told you which equation to follow. Follow the equation that has the reversible arrows. And then you check whether there is OH or not. Okay, and you can see there is OH here. So when OH is being added over there, what will happen? The concentration of OH minus is increased. So what LCP will do? LCP will push the position of the equilibrium to go to the left. Okay, and in that process, OH minus is going to come back as normal. Okay, and then what will happen? The ammonium will decrease, but the decrease of 1, okay, this is 100. It's not going to be visible. There is going to be increase of 1 from what? From 100. Not so visible also. Okay, the same thing, okay, is explained over here. And then the last question, okay, explain why dilute aqueous ammonia alone will not act as a buffer solution. It means they are telling, okay, why, okay, if I just have ammonia plus water, okay, to give you NH4 plus OH minus without the presence of this equation, cannot behave as a buffer solution. Let's see. Okay, let's see what happened. Now, if I have H plus coming in, only with this, okay, H plus coming in, you check, okay, it's going to be reversible, so they will combine with this, okay. When they combine with this, okay, the OH will decrease, okay, the OH will decrease. And what will happen? Okay, the position of the equilibrium will be shifted over there. Okay, then they will replace the OH minus, is fine. Okay, they will increase the NH4, they will decrease this, still fine. I think still fine. It's okay because still formation of 1 minus 1, still no problem. Okay, still no problem. But the problem will arise, okay, when you have ammonia, okay, if I have OH minus. Okay, when you have OH minus, there will be a problem. Now, when I bring in OH minus, what will happen? Okay, OH minus will increase. Okay, OH minus will increase. And then, okay, this OH minus have to go over here. Imagine, okay, there is only one OH minus, one apple, and you are adding 100 apple. Okay, you're adding 100 apple, and there's only one person to eat all the 100 apple. Okay, what happens to the remaining 99 apples? Okay, so that 99 apples will not be eaten. Okay, that is the reason. Okay, if you want to write down the amount of OH minus, the amount of ammonium ion, okay, is not enough, okay, to remove all the OH minus. Okay, that is the reason, and it can be only achieved if I have the ammonium chloride, ammonium ion external. Okay, they will be the one that is going to be helping. I think even here, if you are bringing in H plus also, yeah. Okay, if you're bringing in H plus, we cannot say because H plus will still react with the OH minus. Not enough also. Okay, not enough. Okay, but it's still okay lah, fine for acid. But for base, okay, it's not fine. Yeah, it's not fine. Okay, and then that's the reason why they say the equilibrium will be going to the left. There are not enough NH4 ions. Okay, and to remove the added OH minus ion. Yeah, that is the explanation.